Okay, so we are already on our sample problem number 2. Okay, let's read. A race car C travels around the horizontal circular track that has a radius of 300 feet. So this is the race track C. And then the radius of the horizontal circular track is 300 feet. So, di ba sa projectile motion na atay x and y component, it is because it is moving in a vertical motion. But since curvilinear, movement siya in horizontal or vertical nga movement, that's why we use, instead of the x and y component, we use the normal tangential components of the acceleration. So in this problem, circular iyang motion, radius sa motion sa race car is 300 feet. If the car increases its speed at a constant rate of 7 foot per second squared, starting from rest, determine the time needed for it to reach an acceleration of 8 foot per second squared. What is its speed at this instant? Okay. So first, let's write the given. So sa may given na to. So naay hatag diri nga radius. So this is rho. So radius of curvature is equal to 300 foot. And then if the car increases its speed at a constant rate of 7 foot per second squared. So this 7 foot per second squared is the acceleration. So unsa ni siya nga acceleration? So if you remember, I discussed earlier nga ang direction ni velocity is tangent to the path of motion. So ang unsay direction ni velocity same sa siya og direction ni tangential acceleration. So remember that there are two components for the acceleration. So man siya si acceleration na siya two components, tangential and then the normal acceleration. So ang direction ni velocity og ni tangential acceleration is the same. So ang nag-increase man daw og speed, ang concentrate ang isang speed man, which is the velocity, therefore ang acceleration nga gin-mention din nga 7 foot per second squared is the tangential acceleration. So we write a sub t, tangential acceleration is equal to 7 foot per second squared. Starting from rest, so the initial velocity is 0. So let's write it here. The initial velocity, v naught or vi is just equal to 0. And then we were asked the time needed. So we were asked what is the time needed for the acceleration to reach 8 foot per second squared. So if you notice no, kaning 7 foot per second squared is constant. Unya nga mo increase ang acceleration. So pasabot ani nga acceleration is this one, the magnitude of the acceleration. Combined nga acceleration, tangential, and then the normal acceleration. Sa to pa constant ang tangential, but ang normal acceleration niya in this problem is not constant, ga-increase siya. Okay, so we were asked about the A sub n. So we need to get this normal acceleration. So unsa may una nato buhaton? We have the radius, we have tangential acceleration, then we need the time. So giingon diri nga dapat ang acceleration moabot is, ang magnitude of acceleration is 8 foot per second squared. So si buhaton nato ani. Okay. So let's since ato man daw ni kuan si A, we know that ang magnitude of acceleration A, di ba, is equal to square of the tangential acceleration plus the square of the normal acceleration. Di ba? So kung walaon nato ni ang kuan, ang square root sign, then we raise the whole equation to the power of 2. So mahimo na din siyang a squared is equal to 80 squared plus the normal acceleration squared. So mura rin siyang Pythagorean theorem ra gyud siya. And then we have the tangential acceleration, we have the magnitude of the acceleration 8 foot per second squared, 7 foot per second squared. But we need to get the normal acceleration. So if you recall, normal acceleration nato nga formula is equal to v squared, the square of the velocity over rho. So we have the rho, but we don't know the velocity. initial velocity is 0 but we don't know the velocity at this instant. So ipangitaan po data no what is the speed at this instant. So sa may buhato na to get this v. Ha? So in this problem, since namin na-involve nga constant rate, that is constant acceleration, therefore we can apply the kinematics equation in this problem. Of course, as mentioned before nako, no? So constant acceleration, and then we use the velocity. Katong na velocity, final velocity is just equal to the initial velocity plus the acceleration times the time. Now in this equation, unsa man nga acceleration ang atong gamiton? So if you remember again, di ba nga ang velocity iyang kauban gyud ang acceleration is tangential acceleration. So sa ato pa kani siya nga acceleration is that tangential acceleration. So this is a known. This is 0 because this is the initial velocity. It starts from rest. And then ato ang tangential acceleration is 7, but we don't know yet the time. So we have an equation. The velocity at this instant, katong ni 8 foot per second squared ang acceleration, is just equal to, substitute tangential nga 7 foot per second squared, 7t. Okay? So kung ato ning square, para masubstitute nato dali, v squared is just equal to 49t squared. Okay. So if we substitute na sa normal acceleration here, we can have a formula. Ang normal acceleration is just equal to 49t squared because this is the v squared, the velocity squared, over rho. Rho is 300 feet over 300. So ato ning substitute diri nga equation here, then we can have the a squared. So ang kani siyang acceleration is 8 foot per second squared. So 8 squared is just equal to square of the tangential acceleration, 7 squared, plus the square of the normal acceleration. So this is the normal acceleration. If ato siyang square, and then the whole equation becomes, so 49t squared over 300 square nimo, this becomes 49 over 300 squared. So here, it becomes 2,401 over 90,000 t to the fourth. So ato ning substitute diri, we have 2,401 over 90,000 t to the fourth. Using our basic rule in algebra, all the unknowns on the left-hand side, all the constants is on the right-hand side. So, may mo ni siyang left-hand side ang kuan, ang unknown. 2,401 over 90,000 t to the fourth is equal to 8 squared, transposing 7 squared. So, may mo siyang 7 squared minus 7 squared equals to 64 minus 49. And then 64 minus 49 is just equal to 15. So, para mawala ni nato, we multiply the whole equation with the reciprocal of this one. So, reciprocal, murag bali sa fraction. So, it multiply the whole equation by 90,000 over 2,401. Para kung ato ni multiply diri, cancel ang 90,000, cancel ang 2,400. So, on the left-hand side, this becomes t to the fourth is just equal to, so 15 times 90,000 over 2,401. 15 times 90,000 over 2,401. We got 562.200.2657226. So pagkahuman, so to get the time t, we need to extract this whole equation sa iyang fourth root. So extracting it to the fourth root, kay fourth power man ni diri, our time is equal to, so here, ato lang na i-shift, and then this one, So atong index is 4, and then we input this value 562.2657226. Then our time at the instant nga ang acceleration na to becomes 8 foot per second squared is at 4.8695 seconds. So we already have the time. Next, what we were asked about the speed at this instant. Okay, so we already have the time. Now we are to solve the speed. So ang speed, the velocity v, is na naman the equation, it is here. Therefore, we can solve now for this speed or the velocity. So the velocity at this instant is just equal to 70. So 7 times i-substitution na to ang value sa time, which is 4.8695 seconds. Then our velocity at that instant is just equal to 7 times 4.8695, 34.09 unsa unit. So this is in imperial or English units. Therefore, atong velocity is in foot per seconds.